Hi, welcome to this video, which is going to cover from that practice paper, exercise 4, 5 and 6, this first one. So this is looking at bonding, and the first question asks you to draw potassium bromide, calcium sulfate and magnesium fluoride. So we'll start with potassium bromide. So the first thing we should be able to see is that we have potassium, which is a metal, bonded to bromine, which is a non-metal. So this is an ionic bond. It does tell you in the question it's an ionic bond, but we should be able to spot that, and that potentially could come up in the test, that you have to be able to spot what type of bonding it is and work it out. And so because it's a metal to a non-metal, we've got an ionic bond. Now potassium initially has just one electron in its outer shell. So potassium we can draw like that. So when it becomes an ion, to get a full outer shell, it is going to lose that outer electron. When it loses it, because it's an ion, it's got to go in brackets, and it becomes a single positive. Now I'm just putting positive there. You could put +1 or 1 positive. It makes no difference. Now the electron is going to go to bromine. Now bromine's in group 7, and that has 7 electrons. Now I drew potassium's electron as an X, so I'm going to draw bromine's electrons as dots. This is why it's called a dot cross diagram. And that potassium electron has moved across and it's gone to the bromine in order to fill up bromine's outer shell. So now bromine's got 8 electrons in its outer shell and it's stable. That makes it an ion, and because it's gained an electron, that becomes -1. Where's a sock when you need one? Okay, so question, part B looks at calcium sulfide. So CaS, calcium sulfide. Now, slightly different this time. Previously, we had potassium that just needs to lose 1 electron. Calcium is in group 2, so it needs to lose 2 electrons. Sulfur in group 6, so it needs to gain 6 electrons. I've dotted my around and I put them in kind of what looks maybe like a weird order. Doesn't matter how you put them, as long as you've got 6 electrons and they're dots, calcium's are crosses. So calcium's going to lose its 2 electrons to form a 2 plus. Those 2 electrons are going to go to the sulfur to form a 2 minus. And that is then your calcium sulfide. CaS. 2 plus, 2 minus. Final one is magnesium fluoride. So MgF2, slightly different now. So magnesium fluoride, we've got magnesium, which is a group 2. So 2 electrons. Then our fluorines are group 7. So if 1 electron leaves the magnesium, that's all that's needed to fill up this fluorine and make it negative. So we're going to need, for this second electron of magnesium, a second fluorine to take away that electron. So that electron has now gone to here, and that creates a 2 plus and 2 single minuses, which I've just put as minuses here. You could put it as 1 minus or even -1. It makes no difference how you do it. So that is the ionic bonds. Exercise 5 asks you to draw covalent bonds, and it starts with fluorine, which we've just seen form an ionic bond. Now 2 fluorines bonded together, when we've got F2, is a fluorine bonded to a fluorine. Oh, sorry, I'll get that in screen. So we've got a fluorine bonded to a fluorine, and this line just represents a covalent bond. We know it's covalent because we've got a non-metal bonded to a non-metal. So fluorine, as we said earlier, 7 electrons in its outer shell. So it is going to overlap with a second fluorine, which also has 7, and they're each going to donate 1 electron into a shared pair of electrons in the centre. And now this fluorine's up to 8 electrons in its outer shell, and this fluorine's up to 8 electrons in its outer shell. So they're both now stable, and that is F2. In carbon tetrafluoride, we have our carbon, so CF4, I'll give myself a lot of space, and that is going to form 4 covalent bonds, because carbon's only got 4 electrons in its outer shell. I've represented them by the X's, and then each fluorine also only needs to have 1 covalent bond. We saw that before, so 4 fluorines covalently bond with carbon, and every single species now will be up to 8 electrons. This is often drawn like that. Each of these lines representing the covalent bonds. Final one, hydrogen sulfide, H2S. So again, hydrogen non-metal, sulfur non-metal, so we know it's going to be covalent. With our sulfur in the centre, sulfur is in group 6. So 6 electrons in its outer shell. So to get up to 8, it needs to form 2 covalent bonds, which is why we have 2 hydrogens now attached, and that's our H2S. In exercise 6, we've done covalent, we've done ionic. Exercise 6 asks us about metallic, and it says, draw a labelled diagram of a metallic lattice and explain how it conducts electricity. I am going to draw a group 1 metal, and it's important that you know what type of group you're going to draw, because they're each slightly different. So in a group 1 metal, the most important thing is we have a nice lattice structure. This means they're in nice and neat ordered layers. And on this one, I'm drawing 9 circles in a row. These represent my ions. So a group 1 will form 1 plus ions. I'll put 1 plus on each of those. And now, because they've become 1 plus, our group 1 metal, in order to do that, they've each lost an electron. So I've drawn 9 of them here, so I need to draw 9 electrons. If you'd drawn a group 2, and I'd drawn 9 of them, I'd have to draw 18 electrons. So group 3, 27. 6, 7, 8, 9. Now they go in randomly because they're delocalized and they can move around. The question asks for you to label it. So what we need to label it as, and a different colour pen, we've got here our metal ion, or that iron, we'll get away with this, and this is a delocalized electron. You could possibly get away with free electron, although a delocalized electron is a better term, so will increase your quality grade. And that is exercise 4, 5, and 6. Oh, sorry, we've missed out. How does it conduct electricity? These delocalized electrons, they can move. I've got space there. Let's slide down. Enough space. So we need to mention that delocalized electrons can move, and that is why they conduct electricity.